Okay, so we're back on this problem. I've taken it off of this page right here. Um, and I put it up along beside this because I want you to see what we've already done. And all we're going to do this video is probably just take, we've already done number 1 and number 2, and we're going to take care of number 3 and number 4. Maybe number 5, we'll see. But that's all we're going to do for right now. And then I'll try to finish it up. I know it seems like I'm really chopping it up. It will go a lot faster once you understand all these little parts. But each one of these little parts, like writing that, it wasn't hard, but it took me a long time to explain you. Like all of section 1 was just teaching you how to do step number 2. And so anyway, just hang in there. If it seems like, oh my God, it took her 30 minutes to explain that, the rest of the examples will go faster. So let me get down here to this one. So um, step number 1, it says make sure that you have your population standard deviation. When we take the test, when you take your take home test, the problems are going to be all mixed up. So, and there's going to be 3 different kinds. You're going to have problems where you know sigma, when you know the population standard deviation. That's a Z test. You're going to have those where you don't know it. That's a T test. And then you're going to have proportion problems. That's going to be a Z test with a proportion though. So there's going to be 3 different problems, and you're going to have to decide which one you have just by based on what you read. So did they give us the population standard deviation? There it is. I highlighted it in pink. So yes, we know that. That's how we know we had a t-test. Is it a random sample? Yes, there said right there, a random sample. Well, did they tell us that it was normally distributed? No, they didn't have to, because it's greater than 30. The sample size is greater than 30. So we have 32. Our sample size is 32. So that is how we know that we have a normal distribution. So that's how we are able to now draw that. We understand step 2 right here. The claim is that the pit stop is less than 13 seconds. So we said the mean pit stop is less than 13 seconds. It's less than, so that's how we knew it was the alternative hypothesis. The alternative hypothesis always goes with the one that does not contain equality. Now, the other one, what's the opposite of less than? The opposite of less than is greater than or equal to. So if it's greater than or equal to, since it contains the equality, that's called the null hypothesis, okay? So all of this right here is step number 2. This is step number 2, okay? Now, step number 3 says specify the level of significance, okay? So, is there enough evidence to support the claim at alpha equals 0.01? So this is where we come up with the level of significance, okay? Remember I told you that alpha is the area, and they're telling us right here that the area is 0.01. Now, since this is the area, and I am going to, now that I have that area, the next thing I've got to do is find a critical value. Now, I added that step in there. You want to add that step in there, right, too. It's kind of implied when we specify the level of significance, but we want to be sure that you understand that the reason they gave us an alpha is so that we could find a critical value. And I'm going to jump back over to my notes and show you that those notes are, it explains it right here, okay? Very important vocabulary. A critical value, notice the notation, critical value is Z sub O, and the critical value is going to be the z-score that goes along with that alpha area. So notice that every time they list an alpha, you get a critical value. Alpha and a critical value. You get an area and a z-score. All right? So that's the next thing that we're going to find. We're going to find the alpha, the critical value that goes along with the alpha that they gave us. Okay? Now, how do you do that? Well, you should know that. Okay. Well, first of all, since this is an area, I'm about to find a Z score right here. I'm going to find Z sub O. I'm going to change this to 0. Y'all know why I'm changing it to 0, right? because this needs to be, I want this to be a z-axis. Okay, yes, this is, but you can put your x-axis right underneath that and put the 13 right there if you want to. But I'm going to make that be a 0 because I'm looking for a z-score. Now, we have an area. How do we find a z-score? This is what, chapter 5? You just took your test over it. So how do we do that? You've got 3 choices. You can use a table, you can use a calculator, or you can use StatCrunch. Let's use the table first. See if I've got the table open. Okay. I'm looking for 0.01. Well, here's 0.0099 and here's 0.0102. So 0.01 is somewhere right in between there. Okay. So I'm saying that my critical value is going to be negative 2.3. And I'm thinking it's going to be 3 and then maybe some other decimals, 2.33 and then some other decimals. All right. That's why I like to use StatCrunch or the calculator. I'll go ahead and show you StatCrunch real quick because what do we do? I'll make another video showing the calculator, how to do everything on the calculator, because I'll have to have 2 different videos for calculators. So what are we doing? We want to do a calculator. We want to do a normal distribution calculator. So you click that. And what do we know? We know the area. So remember, this right here is where you put the area. What is our alpha? Our alpha is 0.01. And we want to know a z value. So you compute. And it says, it draws the picture for us. It says that the z value right here is negative 2.326. Now we said it was negative 3.3 something, so negative 3.26. You can use the negative 3.326 or you can round that to 2 decimal places depending on what your homework says. I usually always do z values to 2 decimal places, so I'm going to round that to 2.33. That 6 is going to round the 2 through a 3. And my critical value right here is negative 2.33. Okay, so we found the critical value. Now what we're going to do is we're going to find our test statistic. And that is what our z value is. That's this right here. This is your test statistic. And what we're going to do is once we find Z, which uses all this information that we have over here, once we find Z, then we're going to compare this Z to this Z. And depending on where they are in relationship to each other, we're going to be able to draw some conclusions. So I'm going to go ahead and find the test statistic. You can find it by using the formula. You don't have to use the formula because StatCrunch will find it for you. But if you use the formula, it would be X bar, which is the sample mean, minus the mean of the population, which that's what they're claiming up here, the mean of the population. And then we're going to divide it by this standard deviation of the population divided by the square root of the sample size. And hopefully you remember that what we're doing when we do this right here is we're actually calculating the standard deviation for the sample, okay? We calculate that, and that becomes, you type that in your calculator, and you get negative 2.98. Okay, so we have just found our critical z value. There's our critical z value and our test z value, the critical one and the test one. And in the next video, I'm going to show you how we're going to compare those, okay, and what that means. All right.